Hello students, welcome to the lectures on microcontroller and embedded systems. We are discussing about module 4, the topic being embedded firmware design approach. Okay, so the firmware design approach for embedded system depends on the complexity of the function and the speed of operation required. We have two approaches for firmware design. One is conventional procedure based firmware design, which is also known as super loop based approach, and second approach is embedded operating system based design. Now, let's discuss about these two approaches. For application where the response time is not critical, means the constraint is not about the time. In such applications, we are making use of super loop based approach, and where response time is critical, in such applications we are making use of the second approach. Okay, so moving to the super loop based approach, it is used in applications where the response time is not critical. Here, code is executed task by task, where task at the top is executed first, then the second task will be executed. Likewise, the next task will be executed. You can look at the execution flow. Here you can see in the slide, the execution flow is, we have written some code, main, within which the first thing what we are doing is configuration, then initialization, then about execution of the task. So here the first configuration will be done, that is configuration of common parameters which are required, that will be done. Then second is initialization. What initialization? Hardware components are to be initialized, that will be done. Then the next step is about execution of the task. See, task 1 will be executed first, then after completion of task 1 it moves to task 2, then maybe to task 3. Likewise it goes on till the execution of last task which is defined. Okay, will it move out after executing the last task? No, as you can look at while 1, all these tasks will be executed. If it is true, it is executed for all, and this repeats and repeats again. So this application is non-ending and is repeated. This repetition is by using infinite loop. As you can see here, it is an infinite loop. It has entered into an infinite loop, right? Hence, this approach is super loop based approach. We can get to know why the name is super loop based approach, because it has entered into a non-ending loop. So how to come out of this? That may be your question, right? To come out of this loop, either a hardware reset should occur or an interrupt assertion should occur. Hardware reset brings the program execution back to the main loop, but interrupt request suspends the task, executes the interrupt routine, and restarts the task. In super loop based design, operating system is not required. Operating system in this approach is not required because task scheduling is not present. As we have seen, tasks are executed one after the other from bottom till the end, isn't it? So is scheduling required there? No, scheduling is not required. That's why nothing as operating system role is necessary. So this super loop based design is not having any operating system. But this design is having some drawbacks. One drawback is failure of any part in one task will affect the total system. To overcome this, what they have done, watchdog timer is used. In order to come out of the loop upon failure, they have used watchdog timer. Another drawback of the system is lack of real timeliness. Use of high-speed processor achieves the timeliness. That can come out. We can come out of the second drawback by using high-speed processors. Okay. Next, the second approach we'll go to is the embedded operating system based approach. It contains the operating system. It is containing the operating system. General operating system can be used or a real-time operating system can be used. As you can see in the slide, you can have general purpose operating system or real-time operating system. The general purpose operating system is similar to conventional approach, and user can create and run the applications. Example for general purpose operating system is Microsoft Windows XP, etc. Real-time operating system approach is used in applications with a critical response time. The response time should be critical. In such applications, we are making use of real-time operating system approach. It contains a real-time kernel. It performs preemptive multitasking. It allows flexible scheduling of system resources, maybe CPU, memory, etc. So the system resources as CPU, memory, etc. will be done with the scheduling. Examples will be Windows CE, embedded Linux. These are some of the examples of RTOS. So this is all about embedded firmware design approach. Now, what languages are necessary for the embedded software? That has to be discussed. So going to the next, embedded firmware development languages. The second topic which we will discuss is embedded firmware development languages. So which are the two different types of languages we are using? That is assembly language based development, or it may be high level language based development. So for embedded software development, we can use controller specific language. What is the controller specific language? It is assembly language, or controller independent languages, that are nothing but the high level languages which can be named as C, C++, etc. So let's discuss about these assembly and high level languages. So as we all know, any processor or a controller can understand only zeros and ones. The combination of zeros and ones is nothing but a machine level language. A machine language is a one which the processor understands because it is understanding only zeros and ones. But it's not user friendly. Can all of us remember the combination of zeros and ones in order to move the data, in order to copy the data, in order to rotate the data, and etc.? No. Many operations are there which are to be performed, and for different operations, different combinations of zeros and ones are necessary, and it's very tough for us to understand or remember these. That's why it's not user friendly. That's why the assembly language uses mnemonics, and these mnemonics are easier for the user to remember and use that of machine language. That is, we can remember and we can use than that of the machine language. We need an assembler to convert the assembly language program to machine language. In order to convert the assembly language programming to the one understandable by the processor, that is machine language, this can be done by using what? Assembler. It is the most common type of programming. Which one? Assembly language programming is the most common type of programming. You can see the format of this. You can see here. This is the assembly language. See, we're having 4 fields in the assembly language programming. One is label, opcode, operand, comments. Right. So label, what is label? Label is the optional field. You can have this label or you can leave this. And this label is used as an identifier. Right. Then moving to opcode. This is the second field. Where it is. This is opcode, right? Opcode is nothing but operation code. The operation, what we are doing. The code for the operation which is performed on the data. Right. It is nothing but the operation what we are performing. That's why we are making use of the mnemonic for the required operation that I am writing as the opcode. And what is meant by operand? Operand is nothing but the data on which the operation has to be performed, right? Then about comments, comment will be given what the instruction is doing. As an example, you can look here in this slide, you just can look at move r0, #255. We are not making use of any label part. MOV is the mnemonic which is used for moment that can be acted as opcode. Opcode is nothing but move. Then what is the operand? Operands I'm having mainly in many of the processors. It is processor dependent whether we will have 2 operands, 3 operands likewise. So here I'm having 2 operands R0 and one is an immediate data. Right. So what is performed here? What type of operation? Move R0 comma hash 255 means this data 255. I am moving it to R0. This is the comment written. See, you can look at load register R0 with 50H. So 50H, hexadecimal number 50H is represented as 255. Right. So this data is moved here. One more example may be D, J, and Z R1 comma 0100H. So decrement jump if it is not 0, the content of R0, R1 comma 0100H. Right. So this is again the opcode, these are the operands, right? So this is all about how the format and an example for assembly language program, right? So such instructions for a particular task will be written and that forms a program. This assembly language program will be saved with .asm extension. This is the source file. Whatever instructions I'll write for a particular task forms a program, and that source program, whatever I'm writing for a particular task, will be saved with an extension called as .asm, and that file is nothing but the source file. This source file is to be translated to object file now. Why? Because machine can't understand the assembly language. It has to be converted to a form which will be understandable by the machines. That's why to object file. So what is necessary? Assembler is necessary. So assembler is used in order to translate the assembly code to machine code. Some assemblers are proprietary and supplied by the vendor only. Some assemblers are freely available and some require license from the vendor. Now, how to convert this? That is from assembly language, how we have to convert it to machine language. That is, translation has to be done from source file to object file. You can look at these are the steps. The figure you can look at. These are the steps which are required in order to convert the assembly language to machine language. Right? See, each .asm file can be assembled separately. You can look at this is one .asm, this is one more .asm, this is one more. Likewise, many of the ASM files can be there, and each of these modules are assembled separately. Then assembled is nothing but they are checked for syntax errors and incorrect instructions. After assembling .asm file, this file will be converted to an object file, and that object file will have an extension .obj. Okay, so after assembling the .asm file, we are getting .obj file. This object file does not contain absolute address. That means what? A particular place in the memory is not reserved for it. It is relocatable. Okay, this file is relocatable now. But linker and locator assigns the absolute address to the module. Whatever file we are having .asm, .obj file, this object file is not yet having a address, absolute address, but that absolute address will be given by the linker or locator. Library files will be used by linker, and library files are generated which have an extension .lib. Why we need this library files .lib file? To hide the source code from application developer, library files are generated. So what is this linker and locator? It is used to generate the absolute address to get modules. Linker links any external dependent variable or functions among the modules. Then this object file is to be converted to hex file. What we done is .asm file is converted to .obj file. Then this has to be converted to hex file, right? This is the final stage of conversion. Hex file is nothing but machine code which is understandable and executable by any processor or controller. Now let's see some advantages of assembly language coding. It does less utilization of memory. Efficient memory utilization is the first advantage you can look at. What it means? It makes use of less memory for code and less memory for data. Okay, so less utilization of code memory and data memory is done. That's why efficient utilization is done. The total performance of the system gets improved. That's why high performance is achieved. It provides low-level hardware access. This assembly coding facilitates code reverse engineering. That means what? Using disassembler, assembly code can be got for target machine. We can reverse back and get the assembly code. It has some disadvantages also, that are high development time, developer dependency, and non-portability. That is, what is non-portable? That is, instructions are valid for particular family. For a particular family only, these instructions will be valid, not for all different types of family processors. Okay. Next, in order to overcome these disadvantages of assembly language, high-level languages used. Fine. So an example for high-level language may be C, C++, Java, etc. So program written will be saved with an extension, as if I am making use of C language, it will be with an extension .c. If I am making use of C++, then it will be saved with an extension .cpp. So this file should be converted from high level to machine level again, because high level also will not be understandable by the machine. I have to convert it back to the machine language as we done with the assembly language. So steps for conversion is as shown. Here you can look at. It's almost same as that of what we discussed in the assembly language. The conversion process is shown in the figure. Source file is converted to object file by compiler. See, there we are making use of assembler. Here in high level, we are making use of compiler. Cross compiler will be used. The compiler will be different for different high level code. Rest of the steps are same. You can look at. Once it is created, library files will be used and hex files will be generated, right? It is developer independent and it provides portability. These are some of the advantages. See, reduced development time is one of the advantage. It requires less time for development. Then the other advantage is it is developer independent, but assembly language was developer dependent, right? It is developer independent and it provides the portability. So it also is again having some disadvantages. These are compilers may not be efficient. This may not be efficient in accessing low-level hardware, that is high-level language may not be efficient for accessing the low-level hardware. And last disadvantage is investment for high-level language is high. So this is what all about the assembly and high-level language. Yes, thank you.